Welcome you all to the Research Spark YouTube channel. We are going to start the unit third, that is the electromagnetic waves and waveguides. So here is the syllabus for this unit third. So mainly there are two parts of the syllabus. First is the electromagnetic waves, the introduction, and then the waves in the rectangular waveguides. So in this session, we are mostly going to focus on the plane waves in the different mediums. So mediums either will be the lossy, lossless, free space, and the conductors. So let's start. So first, let's start from the basics of the electromagnetic waves. So in general, what do you mean by the waves? So waves are means of transporting energy or information. As for example, your radio waves, TV signals, radar beams, light rays, or mobile phone you are using, that also, the how are they receiving the energy, how are they receiving the informations due to the waves only. So these are the examples of the waves. So all form of electromagnetic energy share three fundamental characteristics. What are that? So they all are travel at high speed in the traveling speed of light, and they assume the properties of waves all, and they radiate outward from a space without benefits of discriminable physical vehicles. And so how can we categorize the different mediums? So there are the four categories. So here free space, that is sigma is equal to 0, and epsilon naught and mu naught is their permittivity and permeability. Similarly, the lossless dielectric having the sigma is equal to 0 and remaining things, the sigma is less than omega e. Lossy, for lossy dielectric, so sigma should not be equal to 0, and for good conductor your conductivity, that is sigma is equal to, should be infinity or exactly very high. So these are the different mediums that we are going to consider for plane wave traveling. Now, how question is that how can we study the waves? So in order to study the wave, first we need to the bring into the some mathematical format. Then only we can study the waves. So how can we do it? So exactly, wave is a function of both, that is space and time. That is very general one. So in general here, if we are considering, then the it can be written as the wave in the differential equation of the second order. So del square E by dt square minus u square del square E by del z square is equal to 0. So u is the velocity, and so this is the general wave equations of the which can be represented by using the second order differential equation. Now further, if you will solve this second order derivative equation, then definitely you will get the solutions, that is the how the wave equations will be. So ultimately solution will be the sum sinusoidal, like E is equal to A sin omega t minus beta z, that is your omega is frequency, t is time dependent, beta is a constant. So here you will get the sine wave, which is just chosen for simplicity. It may be the cosine wave depending on the phase. So this is the way to represent the general wave. But in our scenarios, we are going to consider the only electromagnetic wave, not the wave. So first of all, now let's try to find out the electromagnetic wave. That is, how can we find out the electromagnetic waves in the lossy medium? First, let's find out the lossy, then we'll do it in the lossless and the other different mediums just by changing the sigma and all the values of the parameters. So now question is that how can we find out the wave equations, the electromagnetic wave equations in this lossy medium? So very simple. First of all, you must remember the four Maxwell equations. So what are that Maxwell equation? So Maxwell equation is your divergence of electric field, magnetic field, and curl of electric field and magnetic field. That's all. So For this case, since we are considering a linear, isotropic, homogeneous, and lossy medium, that is charge free, that is sigma rho v is equal to 0, means there is no charge in the particular region. So that is why the first equation, that is divergence of E, is equal to 0 because there is no charge enclosed. Then divergence of H, that is magnetic field, is equal to 0 because of the single pole cannot exist. And then curl of your electric field, that is minus j omega mu H, and then curl of H is equal to sigma plus j omega E. Yes, so these are the four equations, general Maxwell equations, very simple. Now consider the third and fourth equations, right? So if you are considering third equation, then just take the curl of the uh, equations in both sides, left and right, and then use equation 4 to replace the values. Ultimately you will get the values del square es minus gamma square es is equal to 0. So this is the very general equations of the wave, electromagnetic wave. Now here, what will be the value of gamma square? So just replace the gamma square using the j omega mu sigma plus j omega A. So this is the very important parameters, very important results. So you must remember the gamma square. Gamma square is also called as the propagation constant. So gamma square is equal to j omega mu into sigma plus j omega. So this is the propagation constant. Also, propagation constant will be the actually the combination of real and imaginary part, that is alpha plus j beta. So now our target is to find out the value of alpha and beta. So question is that how can we find out? So we'll have the two unknown and two equations. So if we'll solve one of the equations, we can write gamma square is equal to magnitude, that is equal to beta square plus alpha square is equal to omega mu and square root of omega square plus sigma square plus omega square e square. So since we have the two equations and two unknown, so by using these two unknowns, we can find the values of alpha and beta, and by final values you can observe it here. Let me try to find out highlights. So here is the yes, final values of alpha and beta. So actually you should remember these values because these values alpha and beta we are going to utilize to characterize the different mediums of the uh, plane waves, that is how the plane waves will behave in the different mediums. So all those things will depends on these values of the alpha beta. Why is it so? Because alpha and beta will be the paths of exactly, it will characterize your propagation constant, that is gamma, and gamma is nothing your del square E minus gamma square E is equal to 0. So gamma is a propagation constant, that is how you are going to characterize the fields. So also further, your intrinsic impedance, that is eta, can be written as E naught divided by H naught. That is the electric field, magnitude of the electric field and the magnetic field. So the ratio also you can rewrite it is a j square root of j omega mu divided by sigma plus j omega E. So this is also the important result, but these values alpha and beta are the most important results. So since I can't the in back slides, so please remember these equations alpha and beta further to go ahead. So now let's consider the equation, the case one, that is plane waves in lossless medium. So lossless medium means in this case your loss is very less, means almost negligible, means the conductivity is very high. So sigma is equal to very 0. There is no resistance, and then other parameters if E and mu are there, that is permittivity and permeability. Now put the values of sigma and find out the values of alpha and beta using that equations that we already discussed in the previous slides. So you will get the values of alpha is equal to 0 and beta will be omega square root of mu. And intrinsic impedance can also be found as like square root of mu by. So in this manner, we are characterizing the plane waves in lossless medium. So here, now finally we can find out the gamma. That is, gamma is equal to alpha plus j beta. So gamma will be, since alpha is 0, so the same value will be repeated as gamma, that is beta. So you can use these values to characterize the wave equations. That's all for plane waves in the lossless. Similarly, plane wave in free space. So in this case, gamma sigma is equal to 0 and the permittivity and permittivity. See, again put the values of the alpha and all these values epsilon naught mu and then find out the values of alpha and beta. So alpha again will be 0 and beta will be this one, that is omega square root of mu naught epsilon naught. That also can be written as omega by c. Now further, mu can be written as, from here only, 1 by square root u can be written 1 by square root of mu naught epsilon naught. And so again, propagation constant gamma will be equal to the alpha plus j beta. So put the values of sigma is equal to 0 and these values, you will get the gamma is equal to, since alpha is 0, so gamma will be the again same as beta. Then finally, intrinsic impedance can be written as a square root of mu naught by epsilon naught. If you replace the values of mu naught epsilon naught, then almost the values is 377. So mu naught is almost, the 4 pi into 10 to the power minus 7. Epsilon naught is something like 8.85 into 10 to the power minus 12. So just put all these values because these are the constant values. So you will get the 377 ohm. Now, how the plane waves will behave in the good conductor? So, conductor means alpha is equal to almost, the sigma is equal to almost infinity. That is, conductivity is very high, and epsilon naught and mu naught. So, then put the values all these in that particular equations that we discussed in the general wave equations. Then you will get the value of alpha beta, that will be equal to the square root of omega mu sigma divided by 2. Now again the eta, that is intrinsic impedance, we can find out something like eta is equal to mu omega mu divided by sigma. So if you remember that particular equation, that is general wave equations, the derivation, the solutions, then you can find the values of gamma, that is alpha plus j beta, and by using that only you can solve any equations. So further, skin depth can also be found. Skin depth is a measure of the depth to which the electromagnetic waves can penetrate the medium, and the del is equal to, the 1 by square root of pi f mu sigma. This is one important result. Similarly, skin resistance is a one more result you can use. Sometimes skin resistance 1 by sigma into del, and you can represent it right. Just replace the values, so pi f mu divided by sigma. So these are the some more important results that you should remember. So skin depth, that is del, is nothing, that is 1 by alpha. 1 by alpha is your skin depth, right? So you should remember this skin depth, how to find. So nothing is there. Alpha, exactly question is that how will you find out alpha? So alpha is here. If you remember, for the lossless medium, alpha is 0. So skin depth is infinity, means it can travel to the infinity, means for lossless, no lossless. For good conductor, definitely the skin depth will be limited, and values you can just replace 1 by alpha, that is 1 by this. So that's all in this slides. In the next, we are going to talk about the rectangular waveguides. Thank you for listening. If you have any problem, please drop your comments. Thank you.